in terms of geometry, you are always going to get a question that asks you to prove a theorem, always. It is a guarantee. Go through any past paper, there will be a question somewhere that asks you to prove one of the theorems. So there are, I want to say 6, can't remember off the top of my head now. There are 5 or 6 circle geometry theorem proofs that you have to learn, and then the similarity proportion theorem that we're going to have a look at, which we'll get to. I have never, and I'm not saying that they won't, but I have never seen them ask the proportion theorem proof. It's always a circle theorem proof. So if you are going to hedge your bets, you learn one of your circle theorems, or all of your circle theorems. And the reason I'm saying that is because if you know your theorems, you're guaranteeing yourself 5 to 6 marks. Now, it might not seem like a lot, but remember 5 to 6 marks is the difference between passing and failing, your A and your B, your 30 or 40, whatever the case is. 5 marks is a big deal when it comes down to those nitty-gritties. So you have to make a choice of, I'm either going to learn all of my theorems and guarantee myself those marks, or I'm not going to learn all of my theorems, sacrifice those 5 or 6 marks, but make sure that I'm comfortable with geometry to make it up in my geometry section. That's a choice you have to make. It quite literally is just learning the theorem. So that's why I put it on Google Classroom for you. It's there. You do with it what you will. Yeah, what I've also tried to do in those theorems is I've tried to like put a little like hint for yourself. So even if you don't necessarily learn the proof off by heart, learn the hints. So learn that for, I'm going to be lying to you if I say anything. Learn that for the theorem of line from center to midpoint chord, you have to construct radii. Because once you've got the construction down, you can sort of go from there in terms of where you now need to go in terms of proving. So that's my piece of advice in terms of marks. You can definitely guarantee for yourself, or you're definitely going to sacrifice. That's a choice you have to make. But you will be asked to prove. So don't doubt it. You are going to be asked to prove. It's just whether or not you feel you want to bank those marks. Okay, but let's have a look. So you can see exactly where I've taken the papers from. These are all past papers within the last year or two. So relatively recent. You can see the standard of testing or examining that is happening at the moment and sort of prepare yourself for what's to come. Sorry guys, came out of nowhere. Oh, okay. But let's get started. So this was in the September trial paper from last year. Remember, obviously, Euclidean geometry is a paper 2 topic, so paper 2. In the diagram below, PR is the diameter of circle PQRS with center O. PR intersects with chord QS at T such that PRS is equal to 33. Okay, so there's a lot of information going on here, which is fine, but we don't want to become overwhelmed. So one of the nice little things that I like to work with and that I teach my own kids is Dr. CPT. I don't know how many of you have heard of Dr. CPT, and I'm actually going to spread this out a little bit so that I can actually write. Okay, so Dr. CPT is basically just something that's a useful tool to allow you to look out for certain characteristics within a circle. It's really bad handwriting, but whatever. So this refers to your diameter, your radius, any cyclic quads that you might have, parallel lines, let's go up here, and tangents. Okay, so if you can identify any of these things, or if you've been given any of these things, it's really useful to go and highlight them for yourself or take note of them. So with that being said, according to the information in my question, we were told that PR is a diameter. Now, guys, I would pick a color. So everything I'm highlighting in blue is going to be information that's given to me. So this is the diameter, there's PR. Sort of great highlighting ability that I have here, but we're just going to roll with it. Now, the reason I'm saying pick a highlighter is because geometry is such a visual section. If you're highlighting important concepts, it makes them stand out for you more. And basically it allows you to focus or hone in on those concepts. If this is something that works for you, great. If it doesn't work for you, don't use it. Okay, I'm just giving advice because I do know that geometry is a section that not everyone enjoys. Okay, so we know it's a diameter. We've been told that P intersects with chord QS. So this is the chord. I'm not going to highlight it. I'm just highlighting it for you. Such that angle PTS is equal to 90. So that's given to me there with the block on the diagram. And then angle PRS is equal to 33. And again, that's given to me down there. So that's everything I have. Because of what I've got on my diagram, what we can see is that PSRQ is a cyclic quad because all four vertices touch the circumference. And the next thing that I kind of want you to see is that OP, OS, and if you joined a line from OS to OQ, you would have some radii in this diagram. I'm going to leave those dotted lines off for now, but just, you know, bear in mind that you do have radii on this diagram. Okay, so that's everything that we have, and now we have to go and answer these questions. So I'm going to try and involve you guys as much as I can. Can anyone tell me what the size of angle P1 is? So P1 is there where that circle is. Can anyone give me a size? Give you a second to think about it. You can put it in the chat. You can unmute yourself. I'm really sorry about the noise. Okay, so I've got an answer of 147. Could you maybe explain a little bit how we got there? And guys, remember, in your diagram, nothing's necessarily drawn to scale, but in terms of like acute and obtuse angles, your diagram should show that relatively well. So if you look at P1, it's an acute angle, so we should be getting sort of an acute size. Not necessarily always, but it is like a guide, more or less. Oh. Okay, let's have a look. Now, if we go and have a look at, okay, so some of you are quite close with 33, which is really good. If we go and have a look at the information we have in terms of angles, I've been given the 90-degree angle and I've been given the 33-degree angle. Now, if you look at where P1 is in this triangle PTQ. Now, I don't have any other angles in PTQ, but I definitely know that PTQ here is 90 because of angles on a straight line. And if you go and have a look at this bow tie butterfly shape in pink, we can see that 33 and Q1 are angles in the same seg, which means that, and I'm going to write all of this down nicely with reasons in a second, which means that in that original triangle that I mentioned, PTQ, I have 90, I have 33, and that's going to help me find P1. So always look at the information you have and see if you can get it to where you need it to be in terms of, can you now find angles around the angle you're looking for to help you? Okay, so we obviously need to write all of this stuff down. Angle PTQ, so that right angle is equal to 90 angles on straight line. Now, guys, for geometry, I always say write down everything. Even if you feel like it's really obvious, like this one is really obvious, it's clearly 90, just write it down, just in case. So we've got PTQ is equal to 90. Angle Q1 is equal to 33 because of angles in same seg. I don't know what's happening here. In same seg. And because of all of that, I can now use angles in a triangle to work out P1. So angle P1 would be 180 minus 90 minus 33 degrees. Angles, some angles in triangle. Some of you might have slightly different reasons for angles in a triangle. Some people use interior angles of a triangle. Some people use angles of triangle. All of them are fine. As long as you've been taught it by a teacher, you're fine. And so therefore, angle P1 is equal to 57 degrees. So we had to do a little bit of work before we got to angle P1. But again, because I saw where P1 was and because I saw I had no information around it, I knew that I needed to use the other angles I had been given in order to get there. So look out for angles in same seg, if we had parallel lines, stuff like that. So we had to do a little bit of work before we could actually get to P1. Right now, as I find information out on my diagram, I quite like to write it in. So I now know, so I obviously know that Q1 is 33 degrees because we had the angles in the same seg. And we have just proven that P1 is equal to 57. And the reason I'm also saying write it in for yourself is because once you've got it, you can use it. So now we've got all of these extra angles here, P1 and Q1, I can use them. I'm also using a different color. So all of my important information I had highlighted in blue, and now I'm using a different color to add the information that I have worked out. Just nice to distinguish between the two. You can, you don't have to, it's up to you. All right, so the next angle that I've been asked to find is angle Q2. So that's the angle there with the star. Can anyone tell me what they think we could do here to find angle Q2? Bearing in mind, again, all of the information that we were given. PR is the diameter, and then the angles that we were given and that we worked out. Okay, so have a think. I'm just going to close some of my windows close to us because... Yes, who's there? Kadisile, nice.
And wouldn't you say angles in a semicircle is equal to 90, and then you're going to subtract 33 from 90?
Amazing, excellent. Okay, so guys, remember a diameter, which is PR, subtends an angle at the circumference, so makes an angle at the circumference that is 90 degrees. So that whole angle Q, exactly as Kanisiles just said, is 90 degrees, which means that I can now use that in my reasoning. So PQR, which is that whole angle Q, you could also just say angle Q, that's fine, is equal to 90 degrees. Angles in semicircle. And then because you know the whole angle must be 90, and you've already got 33 degrees of that 90, to get angle Q2, you would say 90 minus 33 degrees. Now, you don't really have to give a reason here. You can if you want. Remember, angles that add up to 90 degrees are complementary angles. So we could say comp angles. It's not really a reason we use a lot, and you wouldn't get a mark for it here. But again, rather write everything down than do something silly. And so we get that Q2 is equal to 57 degrees. Right, so again, once I have information, I like to put it on my diagram for myself. It just helps me sort of know what I have at my disposal to use. So this is 57. Alrighty. 8.2 then says if QS is equal to 16 centimeters, so I'm actually going to choose a different color here. QS is equal to 16, PR is equal to 20. Determine with reasons the length of OT. All right, so we've got our different color. We're adding information. QS, so all the way along there, is 16 centimeters. And PR, so that diameter, is 20 centimeters. And we have been asked to find the length of OT. So OT is this section over here that I've highlighted really badly in green. Right. Now, OT is like just a random line segment. It's not a diameter. It's not an entire chord. It's not a radius. It's just a random line segment. So that's a bit weird. but it's fine. We can deal with it. If we're going to have a look at what we have, so in terms of the information we were just given, remember that any line drawn from your center, so this line drawn from my center OP, that is then perpendicular to a chord, so chord QS, bisects that chord. So it cuts the chord in half. So this diameter OP is actually cutting QS in half. So TS and QT are equal to each other. Now, because that whole thing was 16 centimeters, each of those line segments is 8 centimeters. That's starting to help me a bit, but maybe not. It is, but you know. The next thing that I notice is that I've got a right angle. And right angles are great, especially when they're in triangles, because I can work out lengths of right angle triangle sides using Pythagoras. So if we identify a right angle in which OT lies, right now we can't see a triangle, but remember I said to you earlier, you actually have a radius here, OQ. Just gonna take that line off. So we've got a radius OQ. And we know that all radii in a circle are equal lengths. That's a characteristic of a radius. We were given the length of the whole diameter, PR, and so one radius would be half of that. So one radius is 10 centimeters, which means that OQ is 10 centimeters. And now if you have a look, we actually have a right angle triangle, QTO, in which we can use Pythagoras to work out what OT is. Okay, so it's really important that you do look out for these things. And guys, remember, we don't give you any useless information in geometry. Okay, everything we give you has a purpose. So because I had that line from center through my chord and I haven't used it yet, I'm probably going to have to use it here. I've got the length of a diameter. We have the diameter. We can work out the radius. So all the information we give you is really important. So if we go and set up what we need to do here and just write down everything, we know that QT is equal to TS because line, I hate these reasons, they're so long. Line from center perpendicular to chord. And I know I'm being dramatic, they're not that bad. So that's the 8 centimeters. We also know that the radius OQ is equal to 10 centimeters because our diameter was equal to 20 centimeters. And so now we can go and work out OT using Pythagoras. So I'm going to give you guys like 2 minutes. I want you to work out the length of OT using Pythagoras in that right angle triangle that we identified. Okay, so guys, just remember for Pythagoras, when you have got the hypotenuse and you're looking for one of the other sides, through manipulation of Pythagoras, it'll end up being hypotenuse squared minus the square of the other side that you know. So just be careful. So remember, Pythagoras as a theorem says the hypotenuse squared is equal to the sum of the squares of your 2 other sides. So A would be side 1 and B would be side 2. So just be careful there and make sure you are solving for the correct unknown. I'm going to give you 1 more minute and we'll have a look. Okay, let's see. Oh, that's weird. Okay, so the hypotenuse, remember, is always opposite your right angle. So the hypotenuse in this case is the radius. We also know that if you think about your trig, but I mean, that's a different story. We've got our hypotenuse, which is OQ. So hypotenuse squared, OQ squared, would be equal to OT squared plus QT squared. Now we are wanting to find OT, and this is what I was saying. If I isolate OT, I'm going to have to take OQ squared minus QT squared in order to get OT squared. So OQ was the 10 centimeters because that was a radius. So 10 squared minus QT, which was 8 squared, is equal to OT. 10 squared is 100. 8 squared is 64, 100 minus 64 is equal to 36. I'm running out of space, so I'm going to carry on up here. So we've got OT squared is equal to 36. Now we just want OT, so we have to square root both sides. And so OT is equal to 6 units. All right, so when having a look at a situation like this, just be mindful of your Pythagoras. When you are actually working through your calculations here. So let's take a screenshot of that, and then we shall have a look at the next one. And guys, just remember, if you've got questions as I go along, please ask. You can interrupt me, you can put it on the chat, but please just ask if you do have questions. But otherwise, take your screenshots. Yeah. Let's have a look at the next one. Whoops. So our next question here, and this is still from September 2023, is saying to us, in the diagram below, O is the center of the circle. And I'm just going to take a little tangent here. Please always make sure that you have actually been given the center before you start assuming things are the center. I know that sounds like a very strange thing, but unless we've told you that a point is the center, you're not sure where the center is. So O is the center of the circle, and KP is a tangent to the circle. LN, the diameter of the circle, is extended to meet KP at P. Straight lines OK, OM, KM, and KN are drawn. Right, so they're just telling us those are all straight lines, which is really useful. So let's just highlight all of those important things again. Remember, I'm going to use blue to highlight the things that are given to me. So we were told that O is the center, and we were told that LN is the diameter. We were also told that KP is a tangent. Weird looking line, but anywho. And then all the rest is sort of just like extensions from and so on. So those are just two really important things, because now we can start thinking about, okay, tangents are perpendicular to radii drawn to the same point where the tangent meets a circle. Tan chord theorem with angles in segments. Diameter, we can start thinking about radii, we can start thinking about angles in the semicircle. These are all really important things. Center, we can start thinking about angled center, angled circumference. So just from the information, we've got a fair amount that we can start mulling over. Alrighty, So the first question is asking us, write down two angles that are equal to 90 degrees. Oh, so have a look and let me know if you have got an angle that is equal to 90 degrees. It doesn't actually say with reasons, so, but it's geometry, so let's try and give reasons where possible. So anyone got any angles equal to 90? Yeah, so Kanisile, I see your message. Can you be more specific about which angles of K? So K has got 4 angles there. Which ones? All of them? Only some of them? I do agree that there's definitely an angle of 90 somewhere there, but which one? Nice. Okay, so Kanisile is saying essentially angles K1, K2, and K3 are equal to 90, and I definitely agree. We've got our diameter Ln. It subtends an angle of 90 on our circumference. Who knows why those lines are so squiggly? It's going to do it again, but whatever. And so this angle here is 90 degrees. So you can, I mean, you can kind of write it how you want, but the easiest is probably going to be to say angle LKN is equal to 90. Now, again, it didn't say with reasons, but I'm going to put a reason, angles in semicircle, just so that we do practice reasons. And you should actually always give a reason in geometry, and we know this. So we now know that that angle there is 90 degrees. I hate everything about what I've drawn, so that's cool. This is 90 degrees. Any other angles equal to 90? We need to label, or we need to give 2. So the second one is a bit trickier, but it comes back to what I said. Think about what you can now use given your information. So we've kind of already used the diameter. The other line that we were given that's important is the tangent. Now remember, a radius is always perpendicular to a tangent at the point where the tangent meets the circle. So actually, we have got another 90-degree angle between the radius OK and the tangent KP, which includes angles K2, 3, and 4. I don't know what's happening. Right, so K2, 3, and 4, also a right angle because of the tangent being perpendicular to the radius. So angle OKP is equal to 90, and our reason tan perp rad. Remember, it's not a super fancy reason, just tan perp rad. Okay, so now we've got these two angles equal to 90, and you can see I'm filling them in as I go. Let's see what the next thing is. Obviously, I'm taking them off as I go as well. Alrighty, so 9.2 says, if K4 equals X, so K4 is this angle up at the top here. Let's just hold that in for ourselves. So if K4 is equal to X, write down the following angles in terms of X, giving reasons. So now it specifically says we have to give reasons. So angle L1 in terms of X. So here's angle L1, circle. We need to figure out what that is in terms of X. Now remember, you know that you've got a diameter, you've got a tangent, and you've already worked out a bunch of things. I'll give you a second to think about it. What is angle L1 in terms of X? I'm actually gonna to better him. So angle L1 is going to be a green dot when it eventually wants to. There we go. No. I'll give you a hint. It's got something to do with your tangent. So one of your tangent theorems is going to need to be used here. Another minute, otherwise I'll let you know what we need to do. Yeah, so Chantal's put a suggestion there, it's tan chord theorem. Absolutely. So we're definitely going to use tan chord theorem. So let me know what you think L1 is in terms of X. Nice. Okay, so Nashika, very good. There's your chord KN. And so we can see we've got the tangent and the angle being created between that chord, and then our tan chord theorem applies. So L1 is equal to X tan chord theorem. That's it. And you can obviously abbreviate theorem to THM, or you can write theorem. I suppose it really is up to you. I abbreviate it because why not? Okay, so now we know that this angle here is also equal to X. This angle here is equal to X. And so the next one is asking me, write down in terms of X, the size of angle K1. So this is now the pink dot over here. So have a think, have a look. Let me know what you think K1 would be in terms of X. Okay, seems like I'm struggling in this one. So guys, what I want you to remember is that OK and OL are radii. And so what that means is that they're equal in length. And so the angles opposite them are equal. So K1 is also equal to X. So OL is equal to OK because they are both radii. That therefore means that L1 is equal to K1 because of angles opposite equal sides. And so K1 is equal to X. So always just keep a lookout for all of your properties that then come from having certain bits of information. So I knew those were radii because right at the start in the question I was told O is the center of the circle. Right, the next angle is angle P. So angle P is obviously way outside of the circle here. So we just need to think carefully. So angle P is over here. Again, I'm going to give you a second to think about it, and then we'll have a look. And I'll give you a hint, you already have all of the information that you need to go and work it out. You just need to look at what you already have carefully. So Chantal's got base angles of a triangle are equal. Which triangle are we talking about? Because just be careful, we can only say that two angles are equal if we know that the sides opposite them are equal. Okay, let's see. So I like where we're going with the idea of a triangle. Like I said, you already have all of the information that you need. So if we look in this big triangle LPK, so the big purple triangle I've just highlighted, you actually already know what the whole angle K is, because remember, you know that K123 is 90, and we told you that K4 is equal to X. So this whole angle K at the top here is 90 plus X. I know that's very neat, but we're getting there. You have what L1 is. And so you can use angles in a triangle to work out what P is. Okay, so I'm just going to write this out neatly for myself. Angle K is equal to 90 plus X. There's no reason for it. It's just you've added things together. And so we can now say that angle P is equal to 180 minus 90 plus X plus that second X at L1. And this is all because of sum of angles in triangle, interior angles of triangle, whatever. So 180 minus 90 is 90. X plus X is 2X, would be minus 2X. And so P is equal to 90 minus 2X. This is still in terms of X, so we've done what they asked us to do. We've written down angle P in terms of X. All right, so just be mindful of, again, what you have, but also what information you've already worked out for yourself. Because as you work out more and more, got hiccups. You've got more information available to you to then use. Okay, so P is 90 minus 2X. Again, I'm going to fill this in on my diagram because it's always useful to have my information. Apparently, I'm not going to fill it in. 90 minus 2X. Cool, so I've got that information. And then the next question here, 9.3, is saying, and I don't know why I've chosen to put it all the way down here. Let's just move that so we can actually work with what we have got going on here. This says, join MP, which is a tangent to the circle, and hence prove that KOMP is a cyclic quad. So let's first do the first set of instructions that they've asked us to do, which is to join MP. We would just quite literally draw a line, join MP. It's then referring to a specific quadrilateral it wants me to work with, KOMP. So that's KOMP. So that quadrilateral over there. It's not the most beautiful looking quadrilateral I've ever drawn, but that's fine. We want to prove it's a cyclic quad. Now, guys, remember there are only 3 ways you can prove it's a cyclic quad. All of them your converse cyclic quad reasons. So either you have to prove that the opposite angles in the cyclic quad are equal to 180, or you have to prove that an exterior angle to a cyclic quad is equal to the opposite interior angle, or you have to prove that angles in the same seg are equal. So those are the different ways that you can do it. You need to think very carefully about how you can now go and work with the information that you have. So just bear in mind, you've been told a few things here. You've been told that this line MP is a tangent. And then just, again, remember all of the things you've already proven. So I'm just going to take this purple scribble off, because just remember you have actually proven that that angle OKP is a right angle. So that's my hint. I'll give you 2 minutes to think about it, and then we'll have a look at how we can prove it is actually a cyclic quad. Any ideas? Okay, so guys, when you are trying to prove a cyclic quad, what I would do is I would look out for those 3 things. So see if you have any exterior angles to your quadrilateral. If you look here, there's no exterior angle drawn anywhere to our quad. So that's going to be quite hard to work with. There's also no, I mean, there are angles in the same seg. So if you look at your bow tie, there are definitely angles in the same seg in this quad. But because we don't actually know those individual angles, it's going to be also quite hard to prove. And none of them are using the fact that MP is a tangent. Now remember, a radius, OM, is perpendicular to a tangent, MP, at the point where they intersect. Opposite angles of a cyclic quad add up to 180. You've just shown that this angle here at K and this angle here at M are both equal to 90 degrees. 90 plus 90, 180. So we've proven it's a cyclic quad. Obviously, we need to write all of this down, but we're going to do that. So we already know that OKP there at the top is equal to 90. We proved that earlier. And again, just write down everything if you're not too sure what to write down. The next thing that we know is that OP is perpendicular. I don't actually know why I'm choosing to write it like that. Let's write it a bit better. OMP, so the angle is also equal to 90 because of tan perpendicular to, to radius. Darting everything in my life. Tan perpendicular to radius. And so because both of them are 90, KOMP is a cyclic quad. And there's two ways you can phrase this reason. Either you say opposite angles are supplementary. Personally, I don't use this reason, but it's absolutely fine if you do. Or as a reason, you can say converse of angles of cyclic quad. So either one is absolutely fine. You don't obviously put both, you put one of them, but either one of those reasons is perfectly acceptable. All right, so I'm just going to take off some of these scribbles because I feel like it's going to be hard for you to see what's going on in your screenshot. So really, really important, grade 12s, when you are looking at this stuff, just identify what information you do actually have according to the question, according to your diagram, so that you can move from there. And remember, we never give you useless information. Okay, we're never going to give you something that has, we're never going to give you something that isn't useful or isn't important in the context of the question. And so every bit of information I give you is useful, is important, and should be used.